analyze the frame as shown in figure by matrix stiffness method. If you have different length of a column, what happens? It creates a sway. This is what it is highlighted in earlier classes. The sway could be created when you have uneven column length. And the second case is you have I here and you have 2 times I. The moment of inertia is higher at one end and lower at the other end. So this is one of the reasons to make a sway. So what happens? The column, if you are loading, there will be a slight deviation. So this frame deflects in one direction. So it might be right hand side or it might be left hand side. This is according to the type of load. So this frame does deflect laterally. So this lateral force is called a sway force. Okay. Now if you want to deal this kind of a problem by using matrix stiffness method, by the following procedures. First thing, you need to find the kinematic indeterminacy. Formula is number of reactions, number of support reactions, or you have 3 number of reaction at fixed end, 3 plus 3 is 6, and at hinged end you have 2, 2 plus 2 is 4, so totally 10 number of reactions are there, and number of joints are 1, 2, 3 and 4. So you have 4 joints, degree of freedom per joint is 3, so 4 into 3 will be 12, so 12 minus number of support reaction is 10, so totally you will be getting 2. So this 2 number of kinematic indeterminacy will be there. So this is one part and you will be having a sway, and this is also a kinematic indeterminacy. So totally you will be having 3 number of kinematic indeterminacy in this problem. And what are they? Here the element coordinates are written. You have 3 number of element, 1 beam and 2 column element, and you have 6 number of nodes here. When you draw the system coordinates, how many kinematic indeterminacies are there? At joint B you have 1 Ki, at joint C you have another Ki. And what is this additional? For all this sway problem, you have to take sway as the additional kinematic indeterminacy. By using the formula, you got 2 as indeterminacy. What are they is, at joint B and joint C, the rotation. But why the new force is being added here? This is created due to the sway, that is non-symmetry of the structure, and hence you will be having kinematic indeterminacy of 3. Now what are they? One is deflection at B, so this is lateral deflection, the frame will be deflecting laterally, and you have theta B and theta C. Theta is rotation at joint B and rotation at joint C. So the size of stiffness matrix will be 3 by 3. If you have 3 kinematic indeterminacy, you will be having 3 by 3 matrix. Okay. Now the step is fixed end moments. Since A and B doesn't have any load, similarly C and D doesn't have load, you will be having 0 bending moment, and you will be having the bending moment for this beam component only, that is minus 30 into 8 square divided by 12 and plus 30 into 8 square divided by 12, which the answer will be minus 160 and plus 160. Okay, now when coming into the step 4, forces in element coordinate are that are the fixed end moments. So at A, at the column member you have 0, at the other column member you have 0, in between that for the beam member you have minus 160 and plus 160. Now the next step is finding fixed end coordinate forces, that is F0. How to find F0? Beta transpose into P0. So you have to find the beta transpose and the P0. Okay, how you got this beta transpose, which I will explain here, and then I will come to that point. Now finding the beta matrix, you have a horizontal force. This is a sway force. When taking the transformation matrix for a sway force, you assume that it is deflecting 1 mm. All the 2 columns will be deflecting, and compatibility condition. For that condition, if 1 mm of displacement is happening at one column, the same will be happening at the other column. So this condition is known as condition of compatibility. What is condition of equilibrium? All the forces are acting in a structure will be 0. So this is equilibrium condition, and this condition is compatibility condition. So you will be having 1 mm of deflection here. You can take the deflection here. This is 1 and this is 4. So what is the stiffness? Force by deflection. What is the force here? 1. And what is the length of the member here? Which is 4. So you have to take minus 1 by 4. Why it is minus? It is the opposite of the moment. So the moment is acting as the clockwise, hence you have to take it as minus. Way will be 1 by 8. Likewise here. So similar to this case, since this is a clockwise side, you can take it as minus at both the ends. So what is the highlighted point here is, when you are considering the sway force, what you have to do is you have to take the stiffness component, and stiffness for the column, stiffness only for the column. So no need to consider the beam, stiffness only for the column. The deflected distance divided by the original length. So this will be the sway. Okay. For this component, applying a unit load, unit moment at the joint B, you will be having 0, 1, 1, 0, 0, 1. So this is the transformation matrix, and for the other case 0, 0, 0, 1, 1, 0. So this is the transformation matrix. So if you compile all the three transformation matrix, so 1 by 4 will be minus 0.25, minus 0.25, 0, 0, minus 0.125, minus 0.125. So this is for sway and this is for non-sway. So this is your beta matrix. Now if you substitute this and if you make transpose, the column will be made into rows, and you can find the values. So row into this column. So if you multiply the third column and fourth column is 0, so this is active here. So your first row into first column will be 0. Now second row into this column will be 1 into minus 160 will be minus 160, and this row into this column will be 1 into 160 will be plus 160. So your F naught is 0, minus 160 and plus 160. What is F of F? Which is force applied at coordinates. So there is no force acting at the joint. Now F of F will be 0, and you can find F of F minus F naught. So F of F component is 0 here, minus F naught value is here. So minus of minus will be plus, and minus of plus will be minus. So this is your answer. Now you can come to element stiffness matrix, that is small k suffix n. And since if you have 3 number of elements, you can take 3 number of element stiffness matrix. Your formula is EI by L 4224, and your first member length is 4. You can divide all the elements, each and every element you can divide by 4, and it will become 4 by 4 is 1, 0.5, 0.51. For the second element, you have the length of 8 and it is 2i. If you substitute I as 2i divided by 8, so this and this will get cancelled and you will be getting 4. The same answer you will be getting here. And for the last element, you have 8 meter and 2i. The same way, if you substitute 2i by 8, it will become I by 4, and you can get EI 1.5, 0.51. So you can assemble that all the stiffness matrix, and it will become this element stiffness matrix, small k. Now you have to find the capital K. How to find capital K? Beta transpose K into beta. Beta transpose is this value, and K just now you have found. Multiply these two values. Now this row into this column. What is active here? 0.25 into 1 minus 0.25 into 0.5. So if you add this two component, you will be getting 0.235. Rest of the component will be 0. Likewise, this row into the second column. 1 into 1 into 1 will be this row into this column. So 0.25 into 0.5 will be the second value minus 0.375, and this row into this third column, which will be 0 into 0 will be 0, 0 into 0. So these two components will be 0 and the rest of the components will be 0. Okay, now you multiply this into this. Likewise, if you multiply, you will be getting one answer, and by that answer you have to multiply these beta matrix. You will be getting K as EI 0.235 minus 0.375 minus 0.188. This answer you will be getting K as 3 by 3 matrix. Before this problem, you got all the sums which you have solved K as 2 by 2 matrix, but if you get 3 by 3 matrix, you need to do much more steps. And how to find the K inverse? So for the next step, you should find K inverse. So what is the next step? Is to find K inverse. How to find K inverse matrix? If you have 3 by 3 matrix, if you want to find inverse of a matrix, what you have to do is 1 by determinant of the matrix into adjoint of the matrix. This is the formula, generalized formula. And what is determinant of M is, see, you will be having 3 by 3 matrix like this. You have to take 1 into this is 1 and multiply these components, 1 into 0 and 4 into 6. So 4 into 6 will be 24, 0 minus 24, and you have to take minus 2 into 0 into 0, 5 into 4. So 5 fours are 20, this is written here. Likewise, if you take the third column, first row, 3 plus 3 into 0 into 6, 5 into 1. So 0 into 6 will be 0, 5 into 1 will be 5. So this is the way to find determinant. The same way you have to find determinant for our case. So what is our case? Our K is here. You have to find 0.25, 0.235 is written here into 2 into 2 minus 0.5 into 0.5. So 2 into 2 will be 4, 0.5 into 0.5 will be 0.25 minus of minus 0.375. So minus of minus 0.375, and you have to multiply 0.375 into 2 minus 0.188 into 0.5. So this will be this answer, and the last one, that is plus, and you have a minus value, minus 0.188, 0.375 into 0.5 minus 0.188 into 2. So you will be getting this third component. So if you simplify this, you will be getting 0.6 as your determinant. So determinant of 3 by 3 matrix is 0.6. Now what to do? You have to find adjoint of M. First determinant of M is over, then finding the adjoint of M. How to find that? Making the rows into columns. So you have to find M transpose. If it is 1, 2, 3, make it as 1, 2, 3. So this row into this column, and second row into second column, and third row into third column. Likewise, you have to make this row into column. You have to find the K transpose. So if you make transpose, 0.235 will be here, and 0.375 is here, and 0.1 minus 0.188 is here. So if you transpose second row, which will be in column, and third row into this column, so you will be getting the same answer only. Okay, now you have to find M transpose. So you had M transpose. What you have to do is you have to find each and every square form of this matrix. So first take these four components, that is 1, 6, 4, 0 you have to take, and then you have to take 2, 6, 3, 0 and the next component, 2, 1, 3, 4 as the next component. Next, this second row and this column will get cancelled. You will be getting 1, 5, 3, 0. So if you are taking the second row and this row and this column will get vanished, you will be getting 0, 5, 4, 0. And if you take this component, this center row and center column will get vanished, you will be getting 1, 5, 3, 0, 1, 5, 3, 0. And if you take the next component as 6, these two components will get vanished, 1, 0, 3, 4. You have to take the next one. That is, if you take this L 0, 5, 1, 6, this is taken, and you have to remove this component, you will be getting 1, 6, 5, 2, 1, 6, 5, 2, and the last one as 1, 0, 2, 1. This is the way to find M transpose. The same way you have to do it for this case. If you are finding 2 into 2 is 4 minus 0.5 into 0.5 will be 3.75. Likewise, you have to do the same component for our condition. So this is a model, this is our given case. So you will be getting these values as this components. After getting that, you have to find adjoint of M. What is adjoint of M? The example as minus 24, minus 18, 5, minus 20, minus 15, 4. Likewise, you got this answer. You have to multiply with this factor. So this is a operator. So you have to make this plus, minus, plus, minus, plus, minus, plus, minus, plus. So these are all the mathematical things, which is a process which you have to do. So if you multiply minus 24 into plus, you will be getting minus 24, minus 18, minus, you will be getting plus 18. Likewise, you have to multiply each and every parameter. So if you multiply, you will be getting adjoint of M. The same way you have got this value, you have to multiply with this plus, minus, plus. So you will be getting plus here, instead of minus you will be getting plus, and instead of plus you will be getting minus. So if you multiply with this operator, your answer will become like this. Now how to find the matrix inverse? 1 divided by determinant of matrix into adjoint of M. So your adjoint of the matrix you have received, you have to divide by determinant of matrix. So what is our current determinant? Our current determinant is 0.6. So if you divide this component 3.75 divided by 0.6, every element has to be divided by 0.6. So if you have done that, you will be getting this answer. 3.75 by 0.6 will be 6.25, and 0.656 divided by 0.6 will be 1.093. Likewise, you will be getting this answer. So now you have to find system displacement U equal to K inverse F of F minus F naught. This value you have already found out here. You have found F of F minus F naught as 0, 160 and minus 160. So the same value you have to take. You have to multiply by the F of F, 0, 160 minus 160. So first row into that column. If you have done that, you will be getting U equal to 1 by EI into this answer. Okay. Now element displacement matrix beta into U. Now this is your U and this is your beta. So first row into this column, and if you are doing that, minus 0.25 into 124 will be this answer. Likewise, multiply this row into this column and your answer will be element displacement matrix. And what is P dash equal to K into delta? Now you know small k, and delta you have found out here. To multiply row into this column, you will be getting P dash as this answer, and finally P naught plus P dash will be, what is P naught, which is fixed end moment, and P dash, which is this value. So if you add that, 0 plus 17.5 will be plus 17.5. Each and every parameter if you add, you will be getting this answer. So this is your final bending moment. So you can see that your first value is 17.5 and next value is 81.7 it is written here, and next value is 81.7, minus 81.7, and minus 120 plus 124. So 123.8 is 124. So you got all the value. You can connect these values the same way where you have done in the moment distribution or slope deflection. You can take the two moments and put either it is clockwise or anti-clockwise. Since both are clockwise, since these two are plus, you have to make a column and put a clockwise moment. This will go and this direction, and if you put a clockwise moment, this will go in right hand side. So this is the way to draw the bending moment. And how to find the positive bending moment? You have to take WL square by 8. 30 into 8 square divided by 8 will be 240. So you can draw this combined bending moment. Okay, this is the process, but if you know these steps, so the steps doesn't vary, but according to your indeterminacy and according to your stiffness matrix, your size varies.